You're 60 years old, no teeth left, joints that ache with every step. You can't run, you can't hunt, you can't outpace a hyena, let alone a lion, and you're living 30,000 years ago. By every survival rule we think we understand, you should already be dead. So why aren't you? This question sounds simple. It isn't. Because the existence of elderly humans in the ancient world breaks almost everything evolution is supposed to predict. Natural selection rewards reproduction, not old age. Once you stop having children, evolution, in theory, has no reason to keep you alive. And yet archaeologists keep finding them. Skeletons of people who lived decades past the point their bodies could hunt, gather, or even chew solid food. Elders with arthritis so severe they couldn't have walked without help. Elders with no teeth, surviving on food someone else had to prepare for them. Someone kept them alive. On purpose. For years. That fact alone should stop you in your tracks. Let's go back to the beginning of this mystery. For most of the 20th century, anthropologists assumed prehistoric life was short, brutal, and over fast. The popular image was simple. Humans died young, maybe in their 20s or 30s, eaten by predators, or wiped out by disease before old age was ever a possibility. That image is wrong. Not slightly wrong, fundamentally wrong. In 2004, researchers analyzing skeletal remains across multiple Paleolithic sites discovered something that upended the entire narrative. A significant number of adult skeletons showed signs of advanced age. Worn joints, degraded bone density, signs consistent with individuals who lived well into what we'd now call their 50s, 60s, even 70s. This is called the grandmother hypothesis, and it's one of the most quietly revolutionary ideas in evolutionary anthropology. Here's the paradox at the center of it. If natural selection only cares about reproduction, an individual who can no longer have children should be evolutionarily irrelevant, useless even. Every calorie spent keeping that person alive is a calorie not spent on someone who could still produce offspring. But evolution doesn't seem to agree. Populations with surviving elders consistently outcompeted populations without them. Why? Because an elder isn't just a mouth to feed, an elder is a walking archive. Think about what knowledge actually looked like 30,000 years ago. There was no writing, no books, no internet. Every single piece of survival information that existed. Which plants were poisonous, which rivers flooded in spring, what to do when a wound got infected, how to predict a coming storm by the way birds moved. All of it lived inside human memory. And memory needed time to accumulate. A 25-year-old hunter might know the terrain around camp. A 65-year-old elder had survived 5 droughts, 3 famines, 2 plagues, and at least 1 volcanic winter. They had seen the rare disaster that happens only once a generation, and they remembered exactly what worked and what didn't. In a world with no written record, an elder wasn't a burden. An elder was the only backup system the tribe had. Let's look at the archaeological evidence directly, because this isn't speculation, it's written into bone. At the Shanidar cave site in present-day Iraq, researchers uncovered the remains of a Neanderthal individual, now known as Shanidar I, who lived roughly 45,000 years ago. This individual was partially blind, missing a forearm, and had a deformed leg that would have made walking extremely difficult. By any reasonable survival logic, this person should have died young, abandoned, or unable to keep up with a mobile hunting group. Instead, the skeleton shows this individual lived for years, possibly decades, after these injuries occurred. Someone fed him, someone protected him, someone carried him when the group moved camp. This wasn't an isolated case. Similar findings have emerged across Paleolithic sites worldwide. Individuals with severe disabling injuries who nonetheless survived for extended periods after the injury occurred. The bones heal, they remodel, they show years, sometimes decades of continued life. In evolutionary terms, this is bizarre. In human terms, it's something else entirely. It's care. Now here's where the story gets even more interesting, because survival wasn't just about charity, it was strategy. Anthropologists studying modern hunter-gatherer societies, the Hadza in Tanzania, The Aché in Paraguay, groups whose lifestyles closely mirror ancient patterns, have documented something remarkable. Elderly members of these communities, despite reduced physical capability, often contribute more calories to the group through gathering than younger hunters contribute through hunting. Hunting is unreliable. A skilled hunter might fail to make a kill for days. Gathering, by contrast, is steady. And elders, who know exactly where every edible root, fruit, and nut grows across an enormous radius of territory, who know precisely when each plant ripens, who remember locations from 40 years of walking the same land, are often the most efficient gatherers in the entire group. An elder wasn't dead weight. An elder was often the most economically productive member of the tribe. But the contribution went even deeper than food. Childcare. In hunter-gatherer societies, mothers often need to travel long distances to gather food or hunt small game. Someone has to watch the children. That someone is frequently a grandmother. This is the actual core of the grandmother hypothesis. Human children take an extraordinarily long time to become self-sufficient compared to almost any other species on the planet. A human child can't feed itself reliably until well into its teenage years. That's an enormous, multi-decade investment of resources per child. Mothers who had a grandmother nearby to help feed and protect children could have more children sooner and lose fewer of them to starvation, accident, or predation. In other words, the presence of elders directly increased the survival rate of the next generation. This created a feedback loop. Tribes that protected their elders raised more children successfully. More children meant more hunters, more gatherers, more knowledge keepers in the next generation. And those children, raised by grandmothers who survived, were statistically more likely to also care for their own elders when the time came. Evolution didn't just tolerate elderly humans. It selected for the social structures that kept them alive. There's also a psychological dimension to this that we rarely talk about. Elders weren't just practical resources. They were emotional anchors. Burial sites across the Paleolithic world show evidence of elaborate, careful burial practices for elderly individuals. Bodies positioned with intention, surrounded by tools, ornaments, sometimes flowers. These weren't quick disposals. These were ceremonies. A tribe that buries its elders with that much care is a tribe that valued them in life. You don't develop elaborate grief rituals for individuals you saw as disposable. Now, let's address the obvious question. Did every elder survive? Of course not. Famine happened. Resources ran out. There are documented cases, particularly in extreme environments like the Arctic, of elderly individuals voluntarily removing themselves from a group during severe resource shortages. A heartbreaking but pragmatic act, sometimes framed within cultural traditions that gave it meaning and dignity rather than abandonment. But these were exceptions born of extreme scarcity, not the rule. The overwhelming archaeological pattern, across tens of thousands of years and dozens of regions, points in one consistent direction. Communities went to extraordinary lengths to keep their oldest members alive. So let's return to that 60-year-old we imagined at the start. Toothless, arthritic, unable to hunt. That person wasn't a liability waiting to be left behind. That person was sitting by the fire, telling a child exactly which berries were safe to eat. That person was the only living memory of the last great drought, and knew where the hidden spring was that no one else remembered. That person was holding a baby so its mother could go find food. That person was, in every sense that mattered to survival, irreplaceable. We tend to imagine prehistoric life as a story about young, strong hunters chasing mammoths across the tundra. And maybe that's the more cinematic version. But the quieter, more accurate story is this. Humans survived as a species not because of brute strength, but because we figured out, hundreds of thousands of years before we had a word for it, that knowledge was worth more than muscle. We learned to keep our libraries alive, and those libraries had wrinkles, gray hair, and stories that took 60 years to collect. The next time you see an elderly person struggling to climb a set of stairs, remember this. For most of human history, that person, slow, frail, no longer able to run, would have been the single most valuable member of the group, not despite their age, because of it. We didn't survive as a species by abandoning the old. We survived because we didn't.